Welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 16 from the specimen paper 4 of the Cambridge 0580 syllabus. And this is the extended paper and the new syllabus from 2025. So here we're told about point A and B, and we're given their coordinates 7, 2 and negative 5, 8. And we've got to calculate the length of AB. It is a very straightforward question, and most of you will have memorized the formula for this, okay? And you simply do the following. Now, I'm going to try to explain it in a way which you can visualize what we're going to find. So calculate the length of AB. Sometimes it's written like this. They might say calculate this. It might not mention the length of AB. They might just say calculate this. So you have to understand that means the magnitude or the length of the line between A and B. That's what it means. So you should be aware that you can be asked this question in both those types of formats. So you have to know what this means. Right now, I'm going to show you by way of a sketch, which is not really necessary for you to do in the exam. I'm just showing you so that you get an understanding for those of you who don't understand this formula, where it comes from. So I'm going to make a little sketch of this problem. Okay, so you have your points A and B, and I'm going to put them such that we have, make sure what this is right, sorry, such that you can see what's going on. So you got A is a point 7, 2, so 7, 2, let's say it's somewhere over here. Okay, that's a point 7, 2, so there's 7 there, and that's 2 there. And B is a point to negative 5, 8, so negative 5, somewhere over here, and 8 somewhere up here. Okay, just doing, it doesn't have to be accurate, just doing a rough diagram here. So let's say 8 is somewhere up here. So negative 5, 8 would be up here. Okay, so we have these 2 points. That's a point A, 7, 2, and that's a point B, negative 5, 8. So if I join these 2 points together with a straight line, okay, again, as I said, that's the point B, right? So what we're trying to do here is we're trying to find the length of this line. That's what we're trying to do. And what we can do, and what the formula that we're going to look at actually does, is it makes this into a triangle. So they take the horizontal component, or the difference between these 2 points, and they take the vertical difference between these 2 points, and they form from this a right angle triangle. So here we can see that this length is 7 up to there, and then 5 from there to there. So the total length is 12 units. And here we have the length is from 8 to 2, which is 6 units. So we can use Pythagoras' theorem to find the hypotenuse. Okay, so it's going to be 6 squared plus 12 squared, square root. So this would be the square root of 6 squared plus 12 squared, and that will give us the answer. All right, so the formula for finding the length between 2 points is actually x1 minus x2 squared plus y1 minus y2 squared and square root. So it's basically the same as what we've done here. What we've done is x1 minus x2 squared. Okay, so you have 7 minus 5. Okay, and that's all squared. And you got plus, we got 8 minus 2 squared. Y1 minus y2 squared. Okay, 8 minus 2 squared. All right. In fact, we could do it this way so that we're going in the same direction in terms of the formula. In terms of the formula, you do it in this way. It doesn't make any difference in the end, but we can say 2 minus 8 squared. Okay, it's going to become positive anyway because you're squaring it, and find the square root. So if you have 2 points, A and B, 7, 2, and B minus 5, 8. So you do the square root of 7 minus 5 squared plus, in brackets, 2 minus 8 all squared, and that will give you your answer. As you can see, this is going to give me a 12 squared. I don't need to put this in. I don't need to actually work out what that is. I can just put it in my calculator. This is a calculator paper. There's no problem with that. So I can take this and I can put the square root of 7 minus 5 squared, which is 12 squared. And you're going to have plus, and 2 minus 8 squared, that's going to be negative 6 all squared, which is the same as 6 squared, as we know. If you square negative 6, you're going to get 36. If you square 6, you get the same value. The minus will be squared, give you plus. That gives you 6 root 5. The calculator gives you 6 root 5. It's a good idea to write it down like that first. And then we round it to 3SF. Because it's not an exact answer. That gives you 13.416. So 13.416. So I can write down 13.4 units. Okay. 13.4 units. That's the length of AB, rounding to 3SF at the end. Okay, so there's part A done using the length formula, which is based on Pythagoras' theorem, just for your information. Now, 16 part B says find the equation of the line that is perpendicular to AB and passes to the point 1, negative 3. Okay, so we're going to find the equation of the line which is perpendicular to AB and passes through the point negative 1, 3. So now we have the point A, which is 7, 2. We have the point B, which is negative 5, 8. Let's make sure that I wrote that correctly. Okay, so basically, if we think about it, it passes the point negative 1, 3. Okay, so somewhere up here. Okay, and it's perpendicular to AB. So it's a line that's perpendicular to AB. Okay, so what we can do is we can find the gradient of AB and then find the perpendicular line to that. So the gradient of AB is going to be, you can say, let's do it this way if you want, 8 minus 2 over minus 5 minus 7. The change in y over the change in x. Okay, so 8 minus 2 is going to be 6, and minus 5 minus 7 is minus 12. You're left with negative a half. Okay, so that's the gradient of the line AB. So we want to find what's perpendicular to AB. Okay, so the line which is perpendicular to AB, okay, the gradient of that line is going to be equal to the negative reciprocal of AB. Now, the negative reciprocal means you take the fraction that it is, you change its sign so it becomes positive, and you flip it upside down, you're left with 2 over 1. So that's 2. The gradient of the line is 2, and we know it passes through the point minus 1, 3. So to find the equation of a straight line, we need 2 things. We need to know its gradient, and we need to know at least one point that it passes through. If we have those 2 things, we can find the equation of that line. And there's 2 different ways of dealing with it in terms of 2 different equations you can use. I'm going to show you both of them because I prefer one of them to the other, and I'm trying to encourage students to use that. But the traditional method, what most people would use, is say y equals mx plus c is the equation of a straight line, the general form. So here we know the gradient that we need, which is 2. And we know this point, this is the x coordinate, this is the y coordinate of that point. So we can simply substitute those values into this. So y is represented by 3. The gradient of the line is basically 2. Okay. Times, and x is minus 1. And then we're going to have plus 6. We're going to find what plus c is. We're going to have 3 plus 2, which is 5. So you end up with 3 plus 2, which is 5. So c is equal to 5. So once we have this and we have the gradient, we can work out the equation. We can write down the equation as y equals mx plus c. So y equals 2x plus 5. Okay, so there's the answer to part B. As I said, there's another method that we can use, which I try to encourage my students to use. Y minus y1 equals m times x minus x1. Okay, so what we can do here, you have y minus the y coordinate of the point that we're using, which is 3, equals m, which is the gradient of the curve of the line, which is 2 there. Then we have x minus the x coordinate, so it's x minus minus 1, so x plus 1. So you end up with y is equal to, that's going to be 2x plus 2 plus 3, which is plus 5. So we have the same answer there for question part B. Whether we do it in this method or that method, we get y equals 2x plus 5. So there we have the answers to this question, question number 16 from this specimen paper B, specimen paper from 2025. Other questions from this paper can be found in the playlist that's going to appear in the top right of this screen at the end of this video. Other questions from the topic of straight line graphs can be found in the playlist that will appear in the bottom right of the screen, end of the video. You can subscribe to my channel by clicking on the link over here, and you can watch the video that will be linked at the top here that shows you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.